Math 3, Unit 3, Section 4. So today you'll notice that we, in addition to graphing, are also going to have to factor the polynomial first. Okay, we practice factoring a lot in Unit 2. Okay, and it's going to keep showing up throughout this year. So if you struggle with factoring, please come in for some extra help. But these are just kind of a review. Whenever you are factoring, check for a GCF first. Okay? If you factor and then you notice that there's a GCF, you can take it out afterwards. Okay? But it's easier to take out the GCF first. If you have a difference of 2 squares, remember to write these both as squares first, like 3 squared, x squared minus 7 squared. And then they get split up into the 2 parentheses. All of your squares are split up. Okay? And then you have your trinomials that we factor, and you can factor that by grouping. Okay? So again, and this didn't print out right, but in general, when factoring, you always look for your GCF first, and then go from there. So, we're going to start, and it says completely factor the following polynomials. How many terms are here? 3. So we're probably going to use our factoring by grouping. Okay, or we can use our shortcut once we get our multiplying and adding number. Is there a GCF here? No. Okay, and so my multiplying number is what? 24, and my adding number is negative 10. Are you guys okay with me just doing M and A for multiplying and adding? Yeah. Or you could do the multiplication sign and adding sign, whatever you want to do. Okay, so remember, if you're ever not sure what multiplies to be 24, you can just list your numbers starting with 1 and 24. And then I go to 2 and 12. And see, I'm going in an order, 1, 2. I could go 3 and 8. But I'm going to stop at 2 and 12 because I know that I can make 2 and 12 equal to negative 10. Specifically, what would need to be negative in order to make them a negative 10? You know what? Good. Let's put that down. Good job. So 6 and 4 could also make 10. I totally agree. And why is actually that one correct? So on this one, if I made the negative 12, and you add those, it makes negative 10, correct? But when you multiply, what happens? It makes a negative 24, so it doesn't work. Okay, and so we keep going on, and then Jordan said, how about negative 4 and negative 6? So when we add both of those, it adds to be negative 10. When we multiply, does it make positive 24? Good. Okay. Now, we have our factoring by grouping. Do we need to use factoring by grouping, or should I just use the shortcut? Is shortcut okay? So the shortcut, and this one, it's going to look slightly different. Normally this is x squared, and so we put an x in front of each of these. But what is this one now? We'll just say x to the 4th, right? So you're always splitting those in half. So when I have x squared, I'm splitting it as an x and an x, so I have a 1 and a 1. But if I have x to the 4th, it's going to be x squared and x squared. Okay, and then one of them will get a minus 4, and one gets a minus 6. Can either of these be factored further?
Yeah.
Shelby.
The negative 10, isn't it an x squared, so it would be negative 4?
So, you know how when we had a, let's pretend that these are not, let's pretend this equation is x squared. And actually, you know what? Let's not do our shortcut. Is that okay? And then you'll see how it works out. Okay, so let's delete that for a minute. And we're going to use our shortcut, which means that we change this negative 10x squared into negative 4x squared and negative 6x squared. And then the x to the 4th still stays at the front, and the plus 24 still stays at the end. Everybody okay with that so far? Okay, so now we're factoring by grouping. So we group the first two together and the last two together. So the first two, what's my GCF? X squared. Okay, so we factor out our x squared. And when we do that, we're dividing each of these by x squared. And what am I left with? X squared minus 4. Because x to the fourth divided by x squared, you'd be able to cancel out two of your x's, and you'd be left with x squared. And then here the x squareds cancel, and we have minus 4. What is my GCF of the next group? Negative 6. And we divide each of these by negative 6, and we're left with what? X squared minus 4. Notice that each of these are the same. They're like, which they're supposed to be. And so when we factor by grouping, our GCF now is x squared minus 4. So I'm dividing each of these by x squared minus 4. And we're left with x squared minus 6. So what happens is when you distribute that, it ends up making your middle x squared term.
But I don't get why we divided by x squared minus 4.
I'm just showing you that when you're at this point right now, you basically have two terms, and there's now a GCF, which is the parenthesis. The parenthesis part is your GCF. Do you see how both of those are the same? Do you?
Yeah, if we do the other way, that's like.
Yeah, because I don't get why you would do x squared
Okay,
minus 4.
time out for just a minute. Okay. In math, there's always multiple ways to solve a problem. Okay? If you recall, I originally did the shortcut. So when you're doing your homework, is it okay to do the shortcut?
Yes.
Yes. Right now, I decided that we should go through the whole process to understand why this ends up becoming the answer and why the shortcut works. You don't have to do this on every problem. In fact, the next problem we cannot do this on, okay? But I'm just showing you. We don't have to get upset with the process. But this really is, x squared minus 4 is a GCF of this problem. And so just like when I had a GCF of x squared and I took out the x squared right here, this now is a GCF, x squared minus 4, and I'm taking out the x squared minus 4. You don't have to show dividing by x squared minus 4 if you don't want to. You can just write x squared minus 4 and the x squared minus 6. That is fine. But I just want you to understand that it actually is a GCF and you're taking that out of the entire equation. Okay? Justin. Okay.
But is it okay, like, if we just, like, because you said it's fine, right? If we just write it like how the parentheses, that's right.
If you get this answer, that's fine. That's fine.
But do you need to do the x squared minus 4 like in other problems, or like we'll always do just doing like the parentheses, like how we factored the x squared minus 6 from the top and then x squared minus 4?
If you want to go straight to the shortcut when it's a trinomial, okay. So yeah, you don't have to show the division. You can, from this point, go to this. Is that what you're asking?
Yeah, because that's what I did. I didn't do the x squared minus 4, but I still left the x squared minus 4 and x squared minus 4.
Okay, yes, that's fine. Okay, can either of these factor further?
Oh, yes.
Yes, because 4 is a difference of squares, right? 4 is also a square. I can rewrite 4 as 2 squared. Do you guys agree? Can I rewrite 6 as a square? No. So, this difference of squares, x squared minus 2 squared, factors to be x minus 2, x plus 2. Yes?
Why is that better? Because when we did this before, for like the negative 10x squared, we didn't put x squared, but on this one we did.
Okay, I'm going to show you that what I did before, let's pretend that this problem isn't an x squared, okay? I'm going to do it right next to it. So same problem, but it's x squared minus 10x plus 24, okay? This middle term, we would change to be negative 6x and negative 4x. Because these are like terms, they add to be a negative 10x. So just like over here, do you see how this middle term is an x squared term? They have to be in the same like terms that they would add to be that like term. Does that make sense? Okay. Anybody else have questions on this? They're good questions. Okay. So this problem is now factored as far as it can be factored. Okay? Till next time. All right. So, same idea here. Okay? Let's see how we do on this one. So again, you notice that it's x to the fourth. So when I'm factoring, what's going to be in the front of each of my parentheses? X squared, right? Did we understand that now? Okay. So my multiplication number is what? Negative 25, good. And my adding number is negative 24. And what two numbers do you think are going to work? 1 and 25. Good. And it's going to be a negative 25. And we always kind of double check. So is 1 times negative 25 negative 25? Yes. And is 1 plus negative 25 negative 24? Yes. Okay, so we're good? Do we want to try to do the shortcut this time? No. Okay, if you want to do the shortcut on your paper, you can. I'm going to go ahead and do the long way one more time to make sure we understand. Okay, so as we go through here, what am I changing this negative 24x squared to be? A positive 1x squared and a minus 25x squared. Now, if you had flipped those around, that's fine. Like if you had put minus 25x squared here and a plus 1x squared here, when you first start, we're going to get different answers, but at the end, we'll be at the same point. Okay, we group these. What is the GCF of my first group? X squared. And when I take out that x squared, what am I left with? X squared plus 1. What's my GCF of the second group? Negative 25. Good. And when I divide each of those by negative 25, what am I left with? X squared plus 1. These match. Okay, so that's my GCF now. So when I write my answer, I have x squared plus 1 and x squared minus 25. Doesn't matter which order my parentheses are in. No, so if you wrote x squared minus 25 first and x squared plus 1 second, that's fine. Can either of these factor further? Which one? Good, the 25, because 25 is the same thing as 5 squared, so I have differences of squares. Now, while 1 is a square, right, why can't I factor that one further? Because it's positive. It has to be difference of squares. So I still have x squared plus 1, but then x squared minus 25 factors to be x minus 5 and x, yeah. And either way, it doesn't matter which, if you did plus or minus first. And just remember that the x squared now is becoming an x and an x. Yes. Correct. It only, when you have the two terms, it only works if it's a difference of squares. Difference meaning subtracting. Destiny.
Why would you write it as x plus 1 squared?
If you wrote it as x plus 1 squared, that really means x plus 1 times x plus 1, which if you multiply that out, you'd get x squared plus x squared, x, and then this makes an x, and this makes a 1, which gives you x squared plus 2x plus 1. So you'll notice that this and this are not the same. And that's why you can't ever take a 2 power and just distribute it through here. Because if I just distribute that 2 through here, you guys would write that as like x squared plus 1. And we can see that x squared plus 1 and what this actually is are not the same. Okay? Yes?
You know how it's x minus 5 and x plus 5? What if it was like x minus 5, x minus 5? What is put x minus 5 squared?
Yes, if you had two of the same things, and then that would be telling you that's a bounce, right? So ultimately, we're factoring now because we're going to end up factoring to use those factors to put them on the graph. So if you did have two of the same thing, you would want to write them as a square so that you realize that it's actually a bounce. Okay? Good question. All right, C, what do I do first? GCF. Is there a GCF? Very good. Negative 3x is correct. So my GCF is negative 3x. So I'm dividing each of these by negative 3x. And what do I end up with? Good. X squared minus 9 is correct. Is this a square? Yes, because 9 can be written as what? 3 squared. So we have negative 3x still in front, and then it becomes what? X plus 3, x minus 3. Okay, so remember that if you need to find the y-intercept of a problem, you plug in 0 for x and simplify to find y. When you're finding your x-intercepts, you set each of the factors equal to 0, and that tells you each of your x-intercepts. Okay, we've been doing that this unit. We're good? Okay, I'm turning the page. This is where we put it all together. Okay. You guys ready? It's gonna be fun. Okay. What do you think we have to do first? Factor. But before we do that, I want to write my degree and my leading coefficient, because right now it's in standard form, and so it's very easy for me to get my degree and my leading coefficient. So what is my degree on this problem? 3. And what is my leading coefficient? 1. Okay, so that's going to help me out a lot, and I won't have to think about that later. All right? Okay, so next we're going to factor. What should I do first when I'm factoring this? And I kind of forget about the y while I'm factoring, and then I add it in at the very end. Okay? So what's my GCF? X. Good. So when I factor out an x, I'm left with what? Good. X squared minus 25. Can that be factored further? Yes, because 25 is actually 5 squared. Okay, and so that factors to be what? X plus 5, x minus 5. And then we really still have a y equals there in front. Okay, I'm going to stop. Are there any questions up to this point? Okay, yes. Yes. Any factors you keep. So everything stays in front. Because now, this should remind you of what we did last time, right? And we're going to set each of our factors equal to what? 0. Okay? So my first one is going to be what? X equals 0. Okay? Is that a bounce or a passing through? Passing through. When do we get bounces? When it's an even exponent. Okay? X plus 5 equals 0 will give me a x equals negative 5. Bounce or pass through? Pass through. Good. X minus 5 equals 0 will give me x equals 5. Bounce or pass through? Pass through. Okay, questions on that step? So remember that when you set this equal to 0, you would add 5 to both sides, and so it becomes positive 5. Remember, whatever's in parentheses actually becomes the opposite. Okay, I'm going to help you out here. So if we take x plus 5 equals 0, we subtract 5 to both sides, x equals negative 5. If I take x minus 5 equal to 0, I add 5 to both sides, and I get x equals 5.
Oh no, okay, I got switched up. I was thinking if it was a negative or a positive, and it's bouncing or passing.
Oh,
even or odd. That's
it's
why.
this is a 1 exponent, a 1 exponent, a 1. So since those are odd exponents, passes through.
Yeah.
Okay. All right. So next step is what? Plot them, right? Plot our x-intercepts. Okay. So we have a 0. We have a 1, 2, 3, 4, 5. And we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118 5, negative 5. And then I'm going to put a P at both of those. Now, do I need to find my y-intercept? No, why not? You already have it. It's at the x-axis and the y-axis, right? At 0, 0. So I'm good there. What should my right end behavior be? Positive infinity. Why? My leading coefficient is positive. Okay? So that means, and if you want to write it here, right end behavior is positive infinity because of that leading coefficient. Okay, what about my left side? Why is it going to negative infinity? Odd degree. So remember, odd degree, opposite. Okay? So that means that our left was negative infinity. Okay, so now we just have to finish it. Okay, so if it's passing through, we pass through, turn around, pass through, turn around. We're good. Okay, questions? All right, let's try E. What's the first thing I should do? Good, GCF is correct, but before I even do the GCF, I'm going to go ahead and go to the side here. I'm going to write that my degree is what? 3, and my leading coefficient is what? And basically that tells me that the right side will go to what? Negative infinity. Okay? And if you want to write the left side, then will go to positive infinity. Okay, so you said factor out a GCF. What is my GCF? Negative 2x. Okay? So we're factoring out a negative 2x. When I do that, I divide each of these by negative 2x. And what am I left with? X squared minus 72 divided by 2 is?
31.
How about 36? Okay. 36, is that a square? Yes, it is what? 6 squared. And you can use a calculator on these if you're having a hard time or you don't want to think about what 72 divided by 2 is. Just so you know my thought process, I can do these in my head. This is how I do it. 70, half of 70 is 35. Half of 2 is 1. And 35 plus 1 is 36. So I kind of break it down into like my 10s and my 1s and I split them and add them together. That's how I do it mentally. Okay. Now, negative 2x. What is this factor to be? X squared minus 6 squared. X plus 6, x minus 6. Can I factor anything further? No. So I'm going to bring my f of x down here. F of x equals, because this is actually an equation. And now I need to what? Good. Set each of them equal to 0. Okay. Find what our x-intercepts are. Anytime you have an x in front, it doesn't matter what number it is. If there's nothing being added or subtracted to it, that x will always equal what? 0. So, x equals 0. Bounce or pass through? Pass through. How do we know? Odd degree. Good. X plus 6 equals 0 will make what? X equals negative 6. Bounce or pass through? Pass through. Again, it's an odd degree. What do I mean by odd degree? Is there's only one x plus 6. 1 is an odd number. What? No, we're talking about the power, the exponent. This has a power of 1. This has a power of 1. This has a power of 1. Okay, if there were 2 x plus 6's, that would be an even degree, and then it would bounce. Okay, we will get a bounce here in a minute. Okay. X minus 6 equals 0 will be x equals 6, and that is also a passing through. Okay, so we're going to go to mark these. We have a point at 0. We have a point at negative 6. We have a point at positive 6. Okay, we know the right end behavior is going where? Negative infinity. We know the left end behavior is going to positive infinity. We figured that out from our leading coefficient and degree. Do I need to find a y-intercept? No, why not? Because we already have it, right? And we know that each of these, I forgot to mark it, but each of them are passing through. So that means you pass through the line and turn around. Pass through the line, turn around, and come back. And we're set. Questions? Okay, moving on to F. This one is the same. The only thing is they're just asking us a couple additional questions. How many x-intercepts means how many times does your line cross the x-axis? That's telling you how many x-intercepts. Relative mins and maxes, that's where it changes directions, right? They just want to know how many mins and maxes. Okay, same thing. Okay, what is my degree here? 3. What is my leading coefficient? 2. What does that tell me about the right end behavior? Positive infinity, because the leading coefficient is positive, which means that my left end behavior is going to be negative infinity. Why? Because it's odd. Good. What's next? GCF. What's my GCF here? 2x. So I take out a 2x, and I'm left with x squared minus 4 plus 4. Oops, this was minus 4x. Good job. Okay, so we have to factor this one a little further. Okay, and so what would be my multiplication number? 4, and my adding number is negative 4. What two numbers will work? Negative 2 and negative 2. Okay, so we still have our 2x in front. I'm going to do the shortcut this time. If you don't want to, you don't have to. But I'm going to. Okay? And so my shortcut, I know I'm going to end with 2 parentheses. Since it's x squared in front, what's going to go in front of each of my factors? X. And then we know that each of the numbers that are going to go in the parentheses are here. So in this case, it's a negative 2 and a negative 2. But how should I actually end up writing this one? X minus 2 squared. Because there's 2 of the exact same parentheses, and then we know that's going to end up making a bounce. So when I write this, I have y equals 2x parenthesis x minus 2 squared. Okay, so when I set 2x equal to 0, anytime I have an x in front, that will always make what? X equals 0. Is that a pass or a bounce? Pass. When I set x minus 2 equal to 0, that's going to make x equals 2. Is that a pass or a bounce? Bounce. Why is it a bounce? There is an even exponent. Okay, there's a 2 there. Okay, so 0 here, passes through, 2, bounce. The right side is going up, the left side is going down. If it bounces, that means it touches, it goes up, it turns around, and look, and then it's passing through, everything works out. Okay, how many x-intercepts? 2. Okay, because even though it bounces here, there's 2 x-intercepts here, and there's not really 2 x-intercepts here. It's only touching one spot. Okay, so there's 2 x-intercepts. How many relative maximums are there? 1. So right here, this right there, that is a max. Okay, there is 1 maximum. And right here, that is a minimum. There is only 1 minimum. So remember that your maximums and minimums are where it has to be changing directions. Okay? All right. I don't feel like we need this last example, so I think we're going to go ahead and stop there.